Hi everyone, this is lecture 3 in which I explain one-sided limits from your course book, which corresponds to section 2.4. So let me share my screen. So we will be covering one-sided limits section 2.4 in this lecture video. And we expand, in this section, we expand limit concept to one-sided limits, okay? Meaning that we look at the limits as x approaches to some finite number x0 from left, from this direction, or from right, from this direction. As you can see from this graph, if we approach this value x0 from left, and we will be denoting approaching from left situation by putting a little minus sign in the upper script. This means that x approaches to x0 from left, then what happens to the values of your function? So let's try to search what happens to the values of your function. You see the values of this given function approaches to number L minus. Then let's look at the right direction. So what happens to the values of your function if x approaches x0 from right? So x approaches x0 from right. This is the notation for approaching from right. Maybe I should choose a different color. So what happens to the values of your function as x approaches x0 from right direction? You see, the values are getting closer and closer to this finite real number L plus. So that I can write this. This is the left-hand side limit of your function as x approaches x0 from left. This means from left. This little upper script means approaches from left, okay? And this limit is L0, L minus if you see from the picture. And what happens if x approaches to x0 from right? You see, this little upper script plus means that approaches from right direction. And this time, you see, if I approach from right, the values of your function, if I approach x0 from right, the values of your function are getting closer to this real number, L plus. If these two values are equal, then you say that limit exists and it is the value L. If they are different, you say that limit does not exist, okay? Let's also write that case down. Okay, so we are looking at the values of your function from left and values of your function as x approaches to this particular value x0 from right. If they happens to be same as L, then you can say that limit exists if they are the same, and you say that limit exists and the limit value is L. What happens if they are not the same? So let's write also that down. If they are not same, if L minus is different than L plus, then you say that limit does not exist. Okay. And you say that limit of your function as x goes to x0 does not exist. So one-sided limits are analyzed like this by looking at your function from different directions like that, from left, from right. Okay, this is our first example. Let me first plug in my computer. Okay, so look at our first example. We see this function, the graph of this function, you can also analyze it algebraically without seeing the graph. If x is less than 0, what happens to this value? If x is less than 0, then absolute sign of x is evaluated as minus x. That's why your function is -1, because then f of x is x divided minus x. After simplify, you get -1. If x is greater than 0, then absolute sign of x is evaluated as itself, plus x. So f of x is evaluated like this. So the value of it is +1. And no definition is given for x equals 0. That's why we have undotted coins at x equals 0. Now, what we want to do, we want to look at the right-hand side and left-hand side limit of this function. So let's start by looking at the left-hand side limit at which point? At this particular point, 0 from left. Okay. I am approaching 0. X goes to 0 from left. Then what happens to the values of your function? You see, the values are always constant when you approach 0 from left. All the values are -1. That's why left-hand side limit is 1. Then I can look at the other one-sided limit, which is x goes to 0 from right. Okay, this time I am approaching 0 from right. And look at the values, all those values that your function take as x goes to 0 from right. Again, this is a constant function. All the evaluated values are 1 if you approach 0 from right. That's why right-hand side limit is 1. And as they are different, what is our conclusion about the overall limit? Since left-hand side limit and the right-hand side limit as x goes to 0 as x goes to origin are different, we say that there is no finite unique number that our function is approaching. That's why limit does not exist here. Okay. So another example that we can understand one-sided limits in details is this one. Okay, this is a function is given. This is a particular f of x function, and the graph looks like this. This is y equals f of x function. Okay, now let's try to understand limits at some particular points. For example, at x equals 7. At x equals -7, sorry, this should be all minuses, by the way. Okay, at x equals -7, what happens to the limit of our function? Let's investigate. So I will look at the limit of this function as x goes to -7 from left. From left means from this direction, -7 is here. So look at the values, look at how your function behaves on the left-hand side of -7 point. So it grows negatively huge. So the values are getting really, really huge negatively. That's why this is -infinity, as you can see. And what happens to the limit of your function as x goes to -7, this time from right? Okay, from left, from right. From right is this direction. Look at the values from right here. You see the values are getting and growing too large. That's why if you get really close to -7, the function will get infinitely many big. So the result of this one-sided limit from right is +infinity. This shows what about the overall limit as x goes to -7 of your function. Of course, since there is no finite unique number that f is approaching, limit does not exist at the particular point -7. Okay, we will do the same analysis at, for example, -5. Okay, what happens? Let's investigate. X goes to -5. From left and right, we will try to understand these two situations. Sorry, let's start with left, then look at right. Left. Okay, I am here. From left, what happens? The values of your function are getting closer to, I guess, to which value? Here, I guess, towards. I think this point is supposed to be 0, okay, as you can see. By the way, okay, from the graph, I think it is kind of like 1/2. Okay, I will write 1/2 here. So we are getting closer to -5 from left. So I look at these values, they are approaching to 1/2. And in the other direction from right, okay, what happens from right? From right, the values are here. They are getting closer and closer to the point -1. You see they are different again. That's why I will conclude here, like similarly in the previous case, since there is no, since left-hand side and right-hand side limits are different, limit as x goes to -5 does not exist for this function. Okay, let's now look at x equals 0 point. Okay, limit of this function. X goes to 0 from left and from right. Okay, from left, and then I will look at from right. I will try to find out these one-sided limits. Okay, now I am around origin. From left, all the values are getting closer and closer to the 0 value, as you can see from this direction. From right, what happens? If you follow the graph, you can see that on the right side of the origin, all the values are getting closer and closer to the 0 value. And in this case, we have a match. The left-hand side and the right-hand side limit are the same, meaning that the overall limit around the origin is 0. Okay? And you can do this analysis, similar analysis at the point 2. Let's also write that down here. At x equals 2, what happens? So limit of our function as x goes to 2, f of x as x goes to 2 from left and from right. Let's try to understand these one-sided limits. Okay, the point 2 is here, and from left, what happens? You see, if I get closer and closer to the point 2, the values of your function are getting closer and closer to this value 2. That's why left-hand side limit is 2. What happens from right? You see this time, as you approach the point 2 from right, the graph, on the graph, follow the graph, please follow the values of your function. They are getting closer to 1. So again, they are different since left-hand side and right-hand side limits as x goes to 2 are not the same. This limit does not exist. Okay? This is how you explore one-sided limits, and then by looking at these one-sided limits, you can conclude the overall limit eventually. Okay, so here is another example, very similar. I put the solution of it in your lecture notes. You can study it by yourself later. And I want to move on with this example. Okay, let's say this point is 1. What happens to this function around 1? What are one-sided limits here? Let's try to investigate. Limit of f of x as x goes to 1 from left and from right. We will try to see. Okay, from left, we are approaching towards this point 1 from left. Then what happens to the values of your function? They are growing too huge negatively. So the values are diverging to -infinity. And from right, what happens? This time, the values are getting too large, positively, so plus infinite. Since there is no unique number that the values of your function stay close, or that the values of your function is approaching, you will conclude that as x goes to 1 does not exist. And let's look at this one. This time, one-sided limits are both plus infinity, right? Okay, let me write this down quickly. X goes to 1 from left. Left is this direction. You see the values are getting too large. from right, okay, from right is this direction again. The values are getting too large. They are both plus infinites. But this doesn't mean that there is a finite limit. You will still conclude that limit of your function as x goes to 1 does not exist because infinity is not a finite number, okay? This limit is infinite, okay? Or you can just give this extra information here. Limit is infinite, but still it does not exist as infinite is not a finite number. So writing this is giving an extra information about the limit which does not exist. You are giving the extra information that, okay, it doesn't exist, but it grows, it diverges to infinity. Still doesn't exist. Limit doesn't exist, okay? Okay, let's move on to the next example. Here you will see different situations where we have limit or where we don't have limit. Let's see. Here at the point 1, right-hand side limit, left-hand side limit, they are both 0, so limit exists and it equals to 0. Still, on this function, limit exists 0. What is the difference between these two graphs? At this graph, f of 1 is defined as 2, but here, f of 1 is defined as 1. And these two pictures explains you that even if the evaluated value of your function is different than the limiting value, sorry, here f of 1 is 0. Even if the evaluated value is different than the limiting value, limit still exists. I mean, the evaluated value doesn't have to be the same as the limiting value. Later in the next lecture videos, we will we will distinguish between these two cases by saying that this function is continuous, but this is not. Okay, what happens at this picture? On this picture, on this graph, we have different one-sided limits, right? As x goes to 1 from left, the values are getting closer to -2. On the other hand, from right, the values of your function are getting closer and closer to 0. Since they are different, limit does not exist. Okay, what happens here? Even if there is a corner and undotted point, even if your function is not defined, left-hand side and right-hand side limits are the same as 0. So that's why limit of this function as x goes to 1 is 0. This is 0. You can see that if you search for left and right-hand side values of your function. What happens here? Here, from left, what happens? Limit of f of x as x goes to, let's say this point is 1. From left, it grows too big negatively, so minus infinity. And from right, what happens? From right, limit of this function as x goes to 1 from right, look at the values. They are approaching to 0. Since they are different, you will conclude that limit of this function as x goes to 1 does not exist. Okay, another example. This is the constant function given as f of x is x. At any value a, the value of this function is 1. So, for example, if you choose a as 3, limit of x as x goes to 3, you will just, without seeing the picture, you can calculate the limits by just evaluating this function at the given point. So insert x equals 3, 3. And also from the graph, you can see that the values of your function are approaching this particular value. Which point you choose, it doesn't matter. Always you will find the point as the evaluated value. So the result of the constant function at any given point is that point itself. Because, this is the identity function because all the values are the same as the points. Okay, what about a constant function? No matter which point you choose, all the evaluations are given as 5 in this particular case. So no matter which point you choose, the result of the limit, the result, for example, you can practice at the point 2, all the values are approaching to this particular value 5. So in this case, where the constant function is defined as not 5, but C, no matter which point you choose, you will find this constant number C, okay? So let's try to look at these 3 examples. In the first example, which is called as the step function, unit step function, we will try to understand the limit of it, whether it exists or fails to exist. So for part A, this is part A, and the expression of this unit u of x is this function. This is g of x given as this one over x. And here, this function is f of x, y equals f of x, and its expression is given like that, sine x 1 over x. So let's try to investigate all these functions. For u of x, look at the one-sided limits. Limit of u of x as x goes to 0 from left. From left, the values of your function are always 0. What happens from right? Limit of u of x from right. Okay, this time you will look from this direction, from right. So the values are always 1. Since they are different, there is no finite unique value that your functions stay close. That's why one-sided limits are different. That's why limit of unit step function around origin does not exist. And let's investigate y equals 1 over x if x is different than 0, and it is defined as 0 when x is 0. Okay, so for this one here, g of x, let's investigate. As x goes to 0 from left, you see that if you approach from left, the values are growing too huge negatively, so it is minus infinity. And limit of g of x, this time look at from right. Look at from right, it grows too big positively, so it is plus infinite. That's why limit of g of x around x is around 0 does not exist again, okay? And finally, let's look at sine 1 over x. This is an interesting function behaving strangely around origin. So if x is greater than 0, it is defined as sine 1 over x. If x is less than or equal to 0, it is defined as 0. That's why. And sine 1 over x is graphed like this. And it is strange. It start behaving strangely around x from right. So it oscillates so fast that it oscillates infinitely many times between -1 and 1. So there is no right-hand side limit here. Okay, let me write this down. So this function, limit of f of x as x goes to 0 from left. From left, it is easy. You see all the values are 0. But if you want to look at the limit of this function from right, then you will see also from the picture that it oscillates too much to have a limit. So the values of the function oscillates between +1 and -1 so fast that there is no finite unique number that it approaches when you approach from right, okay? That's why, because of this infinite many oscillations, you will say that right-hand side limit does not exist. So the overall limit of this given function as x around origin, around x goes to 0, does not exist, of course. Okay. So I think we did enough examples on one-sided limits. By looking at the graphs, maybe it is a good idea now, without having a graph, how can we compute one-sided limits? So algebraically, let's compute these two limits now. So we have an expression and we want to compute the limit of this expression from left from right. Okay, in this first case, what happens? So the point 1 is here and we approach 1 from right. So in fact, you are approaching from here, so you can put x values like 0, 0, 0.1. Then what can you say about this value? Then the value of this absolute sign is what? I mean, the insider point, the difference x minus 1, when x is greater than 1, when you approach from right, this value is positive. That's why this is evaluated as itself without putting an extra minus sign in front of it. That's why then the limit square root 2 x minus 1, you see, from the right direction, since the values are bigger than 1, this is positive, so I evaluate the absolute sign as it is without putting an extra minus sign in front, so these two cancels, meaning that limit is like that. So you can just insert 1 here to see that limit is square root 2 from right. Okay, from left, what happens? This time, the point 1 is here and you approach from left, meaning that you choose points like 0.0009, which is less than 1. That's why in this case, this difference will be negative. And that's why this absolute sign will be evaluated by putting an extra minus sign in front of it, since it is negative. So this resolves everything. From left, square root 2x like that, sorry. Okay. And x minus 1. And as you see, I evaluated this absolute sign by putting an extra minus sign in front of it, then these two cancels. I have what? As x goes to 1 from left, I left with this expression, you can insert 1, so the result is minus square root 2 this time. And the one-sided, since the one-sided limits are different, they are different. So limit of this function, if you want the overall limit of this function containing an absolute sign as x goes to 1, what is it? It is, this limit does not exist because one-sided limits are different, okay? So whenever you have absolute sign in your function, you need to proceed like this by looking differently, left-hand side limit and right-hand side limit, and then you can compare the results of them to conclude whether the overall limit exists or not. Okay, I stop here and end the video. See you in the next video.